Okay, so with this one, bring the x cubed up, so it becomes x to the power minus 3. Take away then 3x to the quarter dx, and now we can integrate this. So we add 1 to the power, so that becomes minus 2 upon minus 2. Take away then 3, we'll add 1 to the quarter, so it becomes 5 quarters. Divide them by that new power, 5 quarters plus c. So if we simplify this, 4 upon 2 is just 2, so it'll be negative 2, negative there. And of course that x to the minus 2 we can take down, so it'll be 2 upon x squared. And then with this then, take the 4 up, so you get 12 x to the power 5 over 4 all over 5 plus your c. So we answered that there. Let's now look at part B. So if we look at part B, it says the diagram shows a sketch of the curve y equals 4 minus x squared. Curve intersects the x-axis of the points A and B. The coordinate C has point C has coordinates 3, 0. Curve the point D lies on the curve, and CD is parallel to the y-axis. Okay, showing your work and find the x coordinates of A and B. Of course, now at A and B, that's where the curve cuts the x-axis. Of course, on the x-axis, y is 0, so you can say that. Okay, so you can say on at A and B, on the x-axis, y is equal to 0. So the curve then, so remind us of the curve 4 minus x squared. So therefore 4 minus x squared is equal to 0, which means x squared equals to 4. So then x will equal plus or minus square root of 4. So x will equal plus or minus 2. Okay, when you square root 4 you get 2. So there you go, we've got then the x coordinates of the points A and B given to us. Okay, so A would correspond to minus 2, B would correspond to the plus 2. Alright, so maybe I'll fill them in there, minus 2 and 2. Okay, and we know this one of course is 3 because the question states that. So then it says find the total area of the shaded regions. You have to be careful, okay, because with this, even though it's just the curve, okay, and there's no other line in place. I know they talk about this line here, but that's just where the area finishes, okay, there. We're interested in the area of the curve in the x-axis between minus 2 here all the way to 3 really, okay. But what you must realize here is the area here, when you integrate it, you actually can end up with a negative result, okay, because you've actually got negative y values here. And if you think about it, when you integrate, you're going to integrate this curve here, and this curve is the y value, right? So if the y value here is negative, then the area is going to turn out to be negative, whereas the area here is positive. And what that means is we need to do them in 2 goes, right? So you split them up. So you call it A1 and A2. So if I do A1 to start with, then you've got the area then of the curve, which is 4 minus x squared dx, between then those 2 points A and B, yeah, which is minus 2 and 2. So when you integrate this, you get 4x minus x cubed upon 3 between 2 and minus 2. So we'll chuck that in, we'll chuck 2 in, and then we take away then when you put minus 2 in. Okay, so be careful with that minus 2 there, use brackets, and we'll work that out. Okay, so 4 times 2 is 8, take away 2 cubed, which is 8 upon 3, take away then bracket, 4 times minus 2 is minus 8, take away then bracket, minus 2 all cubed, all over 3, close big bracket, and you get out 32 over 3. Okay, so that's the area of A1. Now something interesting happens then when you work out the area of A2. So let's remind us that area A2 is the area of the curve between 2 and 3. And it is the area under the curve. And one thing you could do to help you see this is if I turn this upside down, you can see I've got the curve here, and it is the area under the curve, between the curve and the x-axis. Okay, so we can still call it area under the curve, even though when you turn it the right way around it's above the curve, but it's area under the curve between the curve and the x-axis. Okay, so the area under the curve between 2 and 3, A2 will equal between 2 and 3, or 4 minus x squared dx, 4x minus x cubed over 3, of course, between 3 and 2. So if we chuck 3 in, you get 4 times 3 minus 3 cubed over 3, minus then chucking 2 in. Okay, so we get our calculator and we'll work that out. So 4 times 3 is 12, take away 3 cubed is 27 upon 3. Take away then, open bracket, 4 times 2 is 8, take away then 2 cubed, which is 8 over 3, close bracket, and you get your answer out. You notice the answer comes out as negative, and it's exactly what I was expecting, because that is in the negative part of the y-axis. Okay, it's and we're going to have a negative answer out. However, when we think about area, it's got to have a, we're on about the size, aren't we? So actually, area A2 is 7/3. So even though it comes out as negative, the actual size of this area, okay, is positive. Of course, we wouldn't write it as negative. Okay, it's come out as negative because the y values are negative, but ultimately it's area. So we take the size of it, and we just say, look, the area of A2 is 7/3. That's why we did it separately, because we had to sort of recognize that. And when we then get the final answer, all we got to do then is just add them two together. So 32 over 3 plus 7 over 3, okay, which becomes 39 over 3, which of course is 13. Alright, and there's our final answer.